Earth's outermost layer, or crust, is 100 kilometers thick. It is divided into rigid plates called tectonic plates. These tectonic plates float on Earth's liquid mantle, which is made of magma, or molten rock.
In this map there are shown the tectonic plates of Earth. There are 9 main and other secondaries. The biggest plate is the Pacific Plate, with 103 million square kilometers. There are oceanic and continental plates.
The four types of plate boundaries are destructive, collision, constructive, and conservative. All of these movements cause changes in the Earth's crust and can affect human life. Now, a more thorough explanation on each movement, its consequences, and where it can be found.
Eso. Pero paralo.
This is a model of the destructive movement of a plate tectonic. It basically consists on an oceanic plate and a continental plate moving towards each other due to the convection currents of the Earth's layers. Then, as the oceanic plate is relatively heavier than the continental plate, during the movement it is pushed down to the Earth's core, while the continental plate is pushed up to the crust. As a result, the oceanic plate is forced under the lighter tectonic plate, causing high-level earthquakes. Then it melts down and the magma rises up through the cracks in the continental plate.
The destructive movement of the tectonic plates, generates a lot of effects on the Earth's crust. Some of them include violent volcanic and earthquake activity. This specific movement occurs in regions where two lithospheric plates converge, and it mostly occurs in oceanic lithosphere. However, it can also affect continental one. There are several destructive boundaries and formations worldwide, generated by this type of movement. Take for example where the Pacific plate is forced under the Eurasian plate in the Marianas Trench near the Philippines, or where the Nazca plate is forced under the South American plate in the Andes Trench near Peru. In both these cases, strong earthquake and volcanic activity can be seen.
A conservative plate boundary is when the plates move past each other or side by side, moving at different speeds.
As the plates move, friction occurs and plates become stuck. Pressure builds up because the plates are still trying to move. Conservative plate boundary mainly have an effect on the part of the San Andreas Fault in California. Also, this type of plate has a huge effect on the Pacific Ocean.
The conservative plates are mainly found on the ocean floor, where they offset mid-ocean ridges and enable the ocean to spread at different rates. When the pressure is released, it sends out huge amounts of energy, causing an earthquake.
Earthquakes caused by this type of boundary are very dangerous as they occur near to the Earth's surface. This is why there is a constant eruption on the Pacific Ocean and the possibility of having one of the most dangerous earthquakes in the San Andreas Fault.
Constructive plate boundary. Constructive movement happens when plates move apart. As the plates move apart, the magma rises from the mantle to the Earth's surface. This magma is going to form volcanoes in order to fill the gap. Also, a new crust is created as the magma cools. This plate boundary can occur in any type of plates: continental, oceanic, and continental oceanic. Examples: Pacific Antarctic Ridge. It is a constructive tectonic plate boundary which is located in the South Pacific Ocean. It separates the Pacific Plate and the Antarctic Plate. Galapagos Rise. It belongs to a constructive movement which is located between the Nazca Plate and the Pacific Plate. Here we have the Galapagos Island, which is a volcanic zone. Here we can find the Fernandina volcano, which lastly erupted in May the 5th, 2005.
Now, collision movement or plate boundary. So, what is a collision? A collision is a margin that occurs when two plates moving together are both made from continental or oceanic crust. I mean, when two plates are the same For example, oceanic versus oceanic or continental versus continental. Here you can see indicated the continental crust with the lithosphere and the asthenosphere. Here is when both plates crash and it creates earthquake activity. After the crash, you can see that the plates generate an operating level in the continental crust. But you have to take into account that this is not created by one collision, but by many. And Himalayas can be a perfect example of these collisions. And the oceanic collision, it will be the same, but the only difference is that in the continental collision you use less weight and it is not common to get destroyed, while in the oceanic collision you use more weight and it can be more common to get destroyed. And the recent example that we wanted to show was the one of Rochester region that experienced two small collision movements in 5 days. Both were centered several miles below Lake Ontario, less than 100 miles away, but neither boat did any damage and almost no one felt them. Both were oceanic collisions.